Hello, this is Dr. Hanaa Assil and this is Unit 1 of January 2025 in the Pearson Edexcel International A-Level Chemistry. So let us take a look at the questions and discuss the answers. The first question here was, what is the total number of atoms in 8.8 grams of carbon dioxide? So we have mass of carbon dioxide. We can get number of moles. Number of moles is the mass over the molecular mass of carbon dioxide. Of course, we are already given the MR of carbon dioxide, so the number of moles is 0.2 moles. We are asked for the number of atoms. Now, 1 mole of CO2 has how many atoms? 1 carbon, 2 oxygens, so 1 mole of CO2 has 3 atoms, and that means this number of moles we multiply by 3 to get the number of moles of atoms. Now we want the number of atoms. We multiply the number of moles by Avogadro constant, and this gives this answer. How many moles of ions are there in 40 centimeter cubed of a solution of this concentration of magnesium nitrate? Again, we have volume and concentration of a solution. We can get the number of moles of the magnesium nitrate. Concentration times volume. Again, don't forget to divide the volume by 1,000. So this is the number of moles of magnesium nitrate. But we are asked for the number of moles of ions. Now, 1 mole of magnesium nitrate has how many ions? 1 mole of magnesium nitrate has 1 magnesium ion and 2 nitrate ions. So we have a total of 3 ions per mole. So we have number of moles of ions would be the number of moles of the magnesium nitrate times 3. So now we have the number of moles of ions, and that's what we asked for. So that is our answer. A water molecule containing isotopes of hydrogen and oxygen, hydrogen 1 and oxygen 16, has a mass of this. So the water as a whole has a mass of this. Now, what is the mass of 1 unit measured in grams? So we are given the mass of 1 unit of the oxygen, the mass of 1 unit of the hydrogen. So the MR of water using these values is 18.011. That's an exact molecular mass according to these values. And we have the water as a whole is 2.9908 times 10 to the minus 3. So if we divide that by the MR of water, this is the mass of an atomic mass unit. NX04 is an oxide of nitrogen. The percentage by mass of oxygen in this oxide is 69.57%. What is the relative molecular mass of this oxide? So we know it's an oxide of nitrogen, but we don't know how much nitrogen. The percentage of oxygen is this. That means if I want to get the MR, then we need to get first what is the empirical formula and then decide. So how do we get the empirical formula? If the oxygen is 69.57%, the rest of 100 is the nitrogen. Get the empirical formula, that means divide by the molecular mass or the atomic mass of nitrogen, the atomic mass of oxygen. What comes out, divide by the smallest. This gives a ratio of 1 to 2. That means the empirical formula is NO2. But then we are told that it is NX04. So the oxygen should be 4. So if it's a 1 to 2 ratio, that means the nitrogen is 2. So that means that my oxide is N2O4, and based on that, the MR of the oxide is 92. 4 different solutions contain chloride ions. 3 of the solutions contain the same number of moles of chloride ions. Which solution contains a different number? So we're supposed to get the number of moles of chloride ions. 3 of these choices have the same number of moles. We are required to get which one is different. So let's calculate the number of moles of chloride ions for each of these choices. So the first choice is for HCl. We have a certain concentration, a certain volume. Now, concentration times volume is the number of moles. Now, how many chloride ions per mole? HCl has 1. So to get the number of moles of chloride ions, you multiply the number of moles of the HCl by 1. What about FeCl3, ion 3 chloride? The number of moles times how many chloride ions? This has 3 chloride ions. The third choice is magnesium chloride. Again, the number of moles based on these information, the concentration and the volume. How many chloride ions per mole? We have 2. The last choice, sodium chloride, and we have only 1 chloride. So as we see, 3 of them are the same. The one that is different is the one for magnesium chloride. The solution contains 95 parts per million of a solute. What mass of the solute is dissolved in 1 kilogram of this solution? Now, what do we mean by parts per million? You should remember that parts per million means the mass of the solute over the total mass of solution times 10 to the 6. So we're told that the mass of the solute over the total mass of solution, of course it says 1 kilogram, that means 1000 grams, times 10 to the 6, and we're told that is 95 parts per million. Now we need to get what is the mass. The mass ends up being 0.095 grams. A sample of hydrated magnesium sulfate contains 43% by mass of water. What is the formula of this magnesium sulfate? Well, we need to get how much percent water in each of these. So if we're talking about that first choice, we get the total MR. And then we have the part of the water. This is 9 water over the total times 100. If we calculate that, the percent water for that is 57%. We're looking for the one that is 43%. So we do that for each of them, and we find that it is the second choice that has a percent water of 43%. The others are not 43. Ethanoic acid can be produced by the oxidation of butane. The atom economy for the production of ethanoic acid is how much? How do we get the atom economy? Remember, atom economy is the molar mass of the desired product over the total molar masses of all the products times 100. And please remember, when we're calculating atom economy, we take into consideration the coefficients. So this equation gives 4 ethanoic acids, so that is 4 times the MR of ethanoic acid over the total product. So it is 4 times the MR of ethanoic plus 2 times the MR of water. This gives a total atom economy of 87%. The first 4 ionization energies of the elements are shown: gallium, indium, germanium, and tin. Which values are the first 4 ionization energies of gallium? Now, remember that where is gallium? Gallium is in group 3. Now in group 3 means that the first, second, third ionization energies, there should be a huge jump after the third ionization energy. Anything in group 3 will have a huge jump in the first ionization energy in the third ionization energies. So this, we have a jump from the third to the fourth. That could be for gallium. The others are not correct. Sulfur has a higher melting temperature than phosphorus, which is P4. Which is the possible reason for that? You should remember that sulfur is actually a molecule with 8 atoms. It's S8. Phosphorus is a molecule with 4 atoms. Now, why would sulfur have higher melting temperature than phosphorus? Is it because sulfur molecules have a greater permanent dipole? They don't have any permanent dipole at all in sulfur molecules. Sulfur has stronger covalent bonds. We never say one covalent bond is stronger than the other. And the melting temperatures is due to the intermolecular forces, not the covalent bonds inside the molecule. So B is wrong. Sulfur has a giant covalent structure? No. We do not regard as 8 as giant. Giant like diamond, graphite, these are giant covalent structures because they have many atoms with many covalent bonds. So C is wrong. Now, sulfur molecules have more electrons than phosphorus molecules? Yes, because melting temperature has to do with the intermolecular forces. Both of them have simple molecular structures with weak intermolecular forces or weak van der Waals forces, but the more electrons we have, the stronger the van der Waals forces. So sulfur obviously has more electrons in its molecule than the phosphorus, so the intermolecular forces will be stronger than that between the phosphorus molecule. Okay, which species are arranged in order of increasing radius? That means we need to start with the smallest and go increasing radius. Well, let's take a look at the choices that we have. We have choices of potassium, K+, argon, Cl-, and Br-. This is what we're trying to compare. Of course, looking at all of these, it's obvious that bromine should be the biggest radius. It has more shells. Remember that K+ means that potassium has lost its outer shell. So actually, potassium will have 3 energy levels, just like argon and chlorine. Bromine will have 4 energy levels. So basically, bromine is the highest. Whether we removed an electron or we gained an electron, the Br- gained an electron, it's still the highest of the other choices. So our choice would be A or B. Now, looking at the 3 other choices, K+, argon, Cl-, all of these, if you count the number of electrons, they all have 18 electrons. Potassium 19 and lost 1. Argon has 18. Chloride 17 and gained 1. They all have 18 electrons. But the difference between them is the number of protons that are attracting these 18 electrons. And you have to remember, the larger number of protons, positive charges in the nucleus that are attracting these electrons, that means there is stronger attraction forces between the electrons and the nucleus, so the radius is smaller. So potassium has more positive protons attracting these electrons than the argon, and the argon has more than the chloride, and we said the Br is the biggest. Which cation would be the most polarizing? Remember we said if we have a cation, a positively charged ion that is small with a large charge, this should be ionic, but because the positively charged ion attracts the electron cloud around the anion, we call that polarizing ability. So the cation to be polarizing, it should be small with a larger charge. So something in group 2 would be more polarizing than something in group 1, and a small positive charge would be more polarizing than a larger one. In the gas phase, PCl5 exists as molecules. They are trigonal bipyramidal. So that structure we know is called trigonal bipyramidal. Each chlorine atom can be replaced one at a time by a fluorine atom. The two axial chlorines, and he already points that the axial are the ones on top or below, are replaced before the other three equatorial atoms, which are in the same plane with the phosphorus. Now, which of the resulting molecules does not have a permanent dipole? Remember, if the dipoles are in opposite direction, they cancel. But if they're not, then the molecule would have a dipole. So we're looking for the one that does not have a permanent dipole. That means the one in which the polarities cancel. So let's take them one by one. We have PCl4 with 1 fluorines. And he said we replace the axial before the others. So if I have just 1 fluorine, it's axial. And we know that the fluorine is the most electronegative element, so this molecule would have a permanent dipole. Now, what if we replace the other axial chlorine with a fluorine? Now the polarities are in opposite directions and they would cancel. So this molecule does not have a permanent dipole. The others would have a net dipole going towards the fluorines, so my answer here is the second choice. Which hazard warning symbol would be found on a bottle of hexane? First of all, we are required to know the meanings of these hazard symbols. Now, we should keep in mind is hexane. What is the hazard of hexane? Remember that most of the organic solvents are flammable. So hexane or any alcohol, the problem with that or the hazard is that it is flammable. So it should have this sign that indicates that the liquid is flammable. What is the IUPAC name of this compound? We said to name a compound, first we look at the longest chain. Where is the longest chain? This is a chain that has 10 carbons. 10 carbons is decane. Nonane is 9 carbons. Decane is 10 carbons. So the name of this is something decane. Then where are the substituents? We said we start numbering from the side that gives the lower number for the substituents. So we shouldn't start from the left. It will give a very large number. We're starting from the right. So the methyl groups that we have are on carbon number 3 and on carbon number 4. That means we have 2 methyl groups. That is dimethyl, and the number of the carbons on which they're placed is carbon number 3 and carbon number 4. Which statement about the cracking of crude oil is true? Cracking of crude oil, when we do cracking, we know that cracking, what is cracking? It's the breakdown of long chain hydrocarbons into shorter chains using catalysts like aluminum oxide and a high temperature 600 to 700 degrees Celsius. So which of these is correct? cracking of crude oil separates mixtures into pure compounds. That's not cracking. Cracking, we're starting with long chain, breaking it up into shorter chains. So actually, out of these choices, it decreases the number of carbon atoms per molecule. We're breaking down a big chain with a lot of carbons into shorter chains. Bromine and bromine water can be used to test for a carbon-carbon double bond. Now, when bromine water reacts with 2-methyl-butene, now what is 2-methyl-butene? This is 2-methyl-butene. So we're reacting this with bromine water. And remember that when we react a double bond with bromine water, we put bromine first on one carbon and then the OH on the other carbon. So the question is, where will the bromine be placed and where will the OH be placed? First of all, we place it on the two carbons that have the double bond. So C and D are totally wrong. Then we have to add one bromine on one carbon so that the other carbon becomes a carbocation. Remember that forming a tertiary carbocation is more stable than a secondary, more stable than a primary. So if I put the Br as we put it like this, then the carbocation is tertiary. If we put it on the other carbon, the carbocation would be a secondary. So this is the major product that is attacked by the OH, and this is where we put the OH. So the answer to this is that compound. Which of these formula are correct for this compound? So he's saying this compound is called 1,4-diethyl cyclohexene. Is that correct? Yes, it is 1,4-diethyl cyclohexene. So the name, that structure is correct for the name. What about the molecular formula? Well, if we write out all the carbons and all the hydrogens, we will find that yes, it is C10H18. Now, if that is the molecular formula, what is the empirical formula? Remember, empirical formula is the simplest ratio. So if you simplify 10 and 18, yes, the empirical formula would be C5H9. This compound is an alarm pheromone released by aphids, and the question is how many pi bonds and how many sigma bonds in this molecule? Well, if we draw out all of these are all sigma bonds, and the double bonds we know are made up of 1 sigma and 1 pi. So the total number of pi bonds are 4. And the sigmas is everything else, including the double bond, because each double bond has 1 sigma and 1 pi. So the total of all of this comes out to 38 sigma bonds. Which structure is a Z-isomer? You should remember that when we have a double bond between two carbons that have different groups attached to them, then we have a cis-trans isomerism or a Z and an E. If the two groups that have the higher molecular mass are on the same side of the double bond, that's a Z. If they're on opposite sides of the double bond, that's an E. So which of these is a Z? We're looking for something that has the substituents with higher MR. Both of them on the two carbons are on the same side of the double bond. Ethene and 1-chloropropene are the first two members of a homologous series. 1-chloropropene exists as two geometric isomers. First, draw the displayed formula of chloroethene. So how do we draw chloroethene? S means two carbons, ene means a double bond, and this is chloro, that means one of the hydrogens is replaced by a chlorine. Now, 1-chloropropene. How do we draw that? Propene is 3 carbons. So we have a double bond somewhere, that's propene, and we need a chlorine on the end of the double bond to be 1-chloropropene. Remember, if it says displayed formula, you have to draw it displayed, showing all the bonds and all the atoms. Then the question says, explain why chloroethene and 1-chloropropene are members of a homologous series. What do we mean by homologous series? You should know that homologous series is a group of organic compounds. And to be members of the same homologous series, they have to have what? They have to have the same functional group and the same general formula, and you are required to know the general formulas of alkanes and alkenes. Explain why 1-chloropropene exists as 2 geometric isomers, but chloroethene does not. So we're saying that chloroethene cannot form cis and trans, or Z and E. But 1-chloropropene, yes, we can have. That is because in order to have geometric isomers, they must have double bonds between carbons, and each of the carbons attached to the double bond should have different groups. So in chloroethene, the carbon on the left has the same group or similar groups, so it cannot form cis and trans. While chloropropene has different groups attached to each of the carbons of the double bond, therefore we say it has restricted rotation around the double bond, and that's why we can have a cis and a trans, or a Z and an E. Chloroethene and 1-chloropropene are both monomers. Draw the structure of the polymer from 1-chloropropene. So we want to draw the polymer of this. We said to draw the polymer of an alkene, we remove the double bond, make it into a single bond, bond on the right, bond on the left to join to other monomers, and we put the same groups that are attached to each carbon just as they are, and this is the repeat unit for the polymer. The polymer of chloroethene, known as polyvinyl chloride (PVC), is used to make water pipes and gutters, which were previously made of metal. So instead of making the water pipes of metals, we now make it from these polymers. So just 2 advantages of using polyvinyl chloride instead of metal in water pipes. You should know that water pipes, if they're made of polymers, this is better because they have lower density and they will not corrode or will not rust. The diagram shows the arrangement of electrons in the energy levels of a sodium atom. And the question says, give the reason why the 2 electrons in the n equals 1 energy level are represented by arrows pointing in opposite directions. When we draw this, why do we represent the 2 electrons in the 1s with with arrows in opposite directions? The 2s, we have 2 electrons, they have to be in opposite directions. Of course, this is because if electrons are in the same orbital, they must have opposite spins. So having the arrows up and down indicates that the electrons have opposite spins. Explain whether or not all of the electrons in the n equals 2 energy level have the same energy. Well, in the second energy level, I have 2 types of sublevels. I have 2s and 2p. Remember, the 2s has lower energy than the 2p, so not all the orbitals in the second energy level have the same energy. Name the shape of the orbital occupied by the electron in the n equals 3 energy level. Well, we had 3s, and you should know that the 3s has a spherical shape. Okay, this question says samples of germanium consist of 5 isotopes, 4 of which are stable. The 5th isotope is radioactive but with a very long half-life. This means that the isotopic composition is almost constant. Well, we're given information about the first 4 isotopes, and the question is, calculate the mass number of the 5th isotope of germanium, and the total relative atomic mass of germanium is 72.6. So we know that if we multiply mass number of each one times the abundance plus mass number times the abundance and so on, the total of all the 5 isotopes should be 72.6. Well, we don't know the 5th, but we can get the percentage. If these are the percentages of the 4 isotopes, then the rest of 100 will be the percentage of the 5th. So the rest of this, of the 100, is 27.4. So if I say mass number times abundance plus mass number times abundance and so on, plus the abundance of the 5th times its mass number, which we don't know, so we're going to put as x, over 100, all of this should be equal to 72.6, and we need to solve for x. So based on that, x, which is the mass number of the 5th isotope, comes out, according to the calculation, it's 71.59. But remember, this is mass number. Mass number is total number of protons and neutrons. It cannot be a fraction. So we have to round it up. So the mass number of the 5th isotope is 72. Give the main reason why the answer should not be to more than 2 significant figures. I cannot say 51.5 something. So this is because, of course, the mass number is the total number of protons and neutrons, and these are whole numbers, so the mass number should be a whole number. The radioactive decay of germanium-76 forms stable atoms of selenium-76. Compare and contrast the atomic structure of an atom of germanium with an atom of selenium. Now, this is germanium. Germanium, we're told, has a mass number of 76, and from the periodic table I can get that it has an atomic number of 32. Now, selenium, again, we're talking about the mass number 76, but selenium has a different atomic number. So, compare and contrast between the two. Well, both of them, because both have the same mass number, that means they have the same total number of protons and neutrons. But then they have different atomic numbers, so they would have different number of protons and electrons from each other, and the total number of neutrons, which is mass number minus atomic number, would also be different for each of these, and you need to give the correct number of each. A sample of a volatile liquid X was vaporized at this temperature and this pressure. This mass of X occupies this volume. Calculate the number of moles. Of course, we're going to use PV equals nRT. What is the value for each of these? Well, that means if I want to get number of moles, PV over RT, well, the pressure we're given in Pascal. That's what it should be. So we put it as it is. The volume is given in decimeter cubed. Remember, it has to be in meter cubed. So the decimeter cubed I have to multiply by 10 to the minus 3 to make it meter cubed. Now over R, we know that R is 8.31 times the temperature. We are given that the temperature is 473, This comes out to 0.05 mole. Deduce the relative molecular mass of X. Well, what have we been told about X? We have this mass of X and we got the number of moles, 0.05. I can use that to get the MR. The MR is mass over number of moles, and we have that. So the MR of X comes out to be 70. Then we're given information about the percentage carbon and percentage hydrogen in X. So we are required to get the empirical formula. Again, you know that to get the empirical formula, first divide by the mass number. What comes out, you divide by the smallest. This gives a ratio of 1 to 2, and that means that the empirical formula is CH2. We already have a mass number, right? The mass number we found was 70. So in order to get the molecular formula, we get the MR of this empirical. The MR of this empirical is 14. But we know that we calculated it to be 70, so 70 over 14, that means the actual molecular formula is 5 times this empirical formula, so it is C5H10. A few drops of a purple solution of acidified potassium manganate were added to a sample of liquid X and shaken. The solution remained purple. Remember that potassium permanganate originally is purple. If it reacts, it should change from purple to colorless, or it should be decolorized. If that happens, that means either I have something that has been oxidized, like an alcohol oxidized to aldehyde or acid or ketone, or if I have a double bond, then it should react also with potassium manganate. Of course, we found that the formula of the compound X is C5H10, so it's not an alcohol anyway. C5H10 could be an alkene, but if it does not react with potassium manganate, that means it is not an alkene. That means I have no C double bond C. That's what I get from this result. Identify now by name or formula 2 possible structural isomers of X using your answers. We already found that it is C5H10. It's not an alkene, so it has to be cyclic. So one possible structure is this, in which I have cyclopentane, or I could have 4 carbons in a cycle and the 5th is a branch, or actually I could have 3 in a cycle and 2 as branches. So these are 2 of the possible structures of the isomer cyclopentane or methyl cyclobutane. Chlorine reacts with both alkanes and alkenes. 3 steps in the mechanism for the reaction of chlorine with butane to form 1-chlorobutane are shown. Of course, you should remember that butane, an alkane, when it reacts with chlorine, what type of reaction is this? You should remember this is a free radical substitution reaction in which the first step is the formation of 2 free radicals. Now, what is the essential condition for this to happen? In order to break up the Cl-Cl bond, I need ultraviolet light. And then we go into step 2, which we call the propagation step, in which we have the free radical reacting with the alkane to form a free radical, and then that free radical again reacts with chlorine. These are called propagation steps. A different type of step other than the ones shown also occurs in the reaction. Now describe this type of step, including 2 possible examples which might occur in this reaction. We already talked about what? Initiation step, propagation step. What's the third step that we haven't talked about? termination step. We said the third type of steps is the termination step, in which two of the free radicals react together to form a stable molecule. So any of the free radicals could join together to form a stable molecule, and that ends the chain reaction. So I could have these two as examples of reaction between two free radicals to form a stable molecule in the termination step. Okay, so what's the next question? Chlorine is not a polar molecule, but it can react with alkenes through electrophilic addition reactions. First of all, state what is meant by the term polar and why chlorine is not polar. Remember that polar molecule means one end is more positive than the other. This happens when we have differences in electronegativity between the atoms. For example, in water. In water, I have bonds between oxygen and hydrogen. And you know that oxygen is more electronegative than hydrogen. So each of these bonds is polar, with the bonding electron slightly towards the oxygen. So we say the oxygen has a slightly negative charge and the hydrogen has a slightly positive charge. Now the polarities of each of these bonds do not cancel, so all of this molecule is called a polar molecule. Now, what about chlorine? Chlorine is something that has two atoms of chlorine. Both of them have the same electronegativity, so there is no polarity. Both of them are similar atoms. They have no difference in electronegativity, so we say that a chlorine molecule is non-polar. Explain why chlorine reacts with alkenes even though it is not polar. So what happens is the chlorine standing on its own is not polar. But when we have a double bond with electrons in it coming close to the chlorine molecule, this causes what we call induced dipoles. So the electrons in the chlorine molecule move to one end, so that one end now of the chlorine is slightly negative and the other end of the chlorine molecule is slightly positive. This is due to the repulsion between the electrons in the double bond and the electron cloud of the chlorine molecule, and what we get there is called induced dipoles. Sulfur hexafluoride is used in the electric power industry as an insulating gas. It can be used in this way as it is very unreactive. Fluorine reacts with sulfur to form SF6. Impurities of S2F10 and SF4 also form and must be removed because they are too reactive. First of all, so how do we name the compound S2F10? Remember that when we have SF6 up there, we are told sulfur hexafluoride. When we have two nonmetals, usually the name indicates how many of each. For example, we say carbon dioxide or carbon monoxide or sulfur trioxide. So we mention in the name how many atoms of each. So here I have 2 atoms of sulfur and 10 atoms of fluorine. In order to name it, the name would be disulfur decafluoride. From decane, anything that's 10 is deca. So this is 2 sulfurs and 10 fluorines, disulfur decafluoride. Then we have this, and we're told to complete the dot and cross diagram for S2F10, showing the outer shell electrons. Use dots for the sulfur electrons and crosses for the fluorine electrons. And they already wrote the crosses for the fluorine that are not involved in the bonding. So what we have in the bonding is one of the sulfur and one of the fluorine for each of the SF bonds, and between the two sulfurs we have one electron each. And please, if the question specifies a certain notation, you have to follow it. So he wants the dot for the sulfur and the cross for the fluorine. Draw dot and cross of SF4 showing all the outer shell electrons. Well, let's try and draw SF4. So the S has sulfur is in group 6, so it has a total of 6 electrons. We're going to use only 4 of them to bond with the 4 fluorines, and each fluorine has 6 of its own not involved in the bonding. The sulfur also has 2 or 1 lone pair of electrons that are not involved in the bonding. Complete the table showing clearly the shapes of the other 2 molecules and the FSF bond angle. So he did the first one for me. SF6 is sulfur with 6 bonds, so this is obviously an octahedral structure, and the bond angle is 90. What about if we're drawing S2F10? Well, this would be the structure of S2F10, and again the bond angle is 90. What about SF4? Remember we said the SF4 has 1 lone pair of electrons on the sulfur somewhere away from the bonding, and in order to have minimum repulsion between the bonding pairs of electrons, this would be the structure in which one fluorine, remember when we draw a wedged bond, that means the fluorine is pointing towards us. The dotted bond means the fluorine is pointing behind the screen. Now, what is the bond angle? You should realize that the fluorine on top and below are at 90 degrees to the sulfur, and the fluorines on the plane of the sulfur have 120 degrees because we have a lone pair of electrons that takes space in that structure. Justify the shape around the sulfur atom in both SF6 and SF4. SF6, we said it's like this. This is called octahedral. Why is it like this? Again, we said for minimum repulsion between 6 bonding pairs of electrons. What about the shape of SF4? We said SF4, it has 4 bonds, but it also has a lone pair of electrons. So it has to be what we call trigonal bipyramid. So if we're saying what structure is this? This is trigonal bipyramid, and it is like this for minimum repulsion between 4 bonding pairs of electrons and 1 lone pair of electrons on the central atom that repel the bonding pairs of electrons. SF4, S2, F10 are reactive. SF6 is unreactive. So we did the structure of SF4, S2, F10, and SF6. And he's saying the first 2 are reactive, the SF6 is unreactive. So just reasons for this by considering the shape and bonding in each of the molecules. Well, let's see. Why would the first 2 be reactive? First of all, the SF4 has lone pair of electrons. And when we have lone pair of electrons, that makes it polar, it is reactive, it can use these to react. The S2F10, why would it be reactive? Well, that's probably because the SS bond is weak and can be broken. So that makes it reactive. Why is the SF6 not reactive? That means that all the 6 strong covalent SF bonds are difficult to break. And that's the end of this exam. I hope this was useful to you, and good luck in your exam.